Hi, so my name is Marie Mork, as I said. Head of Production Technology with Maersk Oil in the UK. And now, last year, Tommy Angel, the organizer, called us up and said, do you guys have any good interventions to talk about for this conference? I said, nah, we got just subsea wells. We haven't really done anything, but we're planning this one. Now, if we pull that off, we will talk about it. So, yeah, we did, and now I get to stand here. And what I'm going to tell you about today is a subsea intervention we did with Helix and QI, and using a coil hose from an intervention vessel. So what I'll focus on is the pre-work we did and the lessons we learned. So hopefully if you have a similar problem, you can see this as an option. All right, so I've split it into 5 parts. So it's the background and problem statement, the options we considered, the equipment and hardware testing, and a little bit on the operations and the lessons learned. Right, so let me see if I get there. So Balloch is a field in the central North Sea. It's tied into the GP3 producer, or FPSO. It's the second well in the Balloch field. When we drilled it, we have the Piper sand, and below it we have this Devonian formation, and we had heavy losses. We lost like 1,000 barrels in there, and we had to pump quite a bit of LCM to stop the losses. So it was difficult to clean it up before you ran the screens. So when we flowed it back to the rig after the completion, the production wasn't as good as we thought. So, and we pumped about 30 barrels of HCl acid, and that made it worse. But still, when we put it online in May 2015, it was a really good well. It produced quite a bit. But over the next year and a half, it declined rapidly. Okay, what's the reason for this decline? I thought, okay, maybe did we erode the sand screens and we filled the well with sand? Or maybe we collapsed the formation, or did we collapse the screens? Or could we have plugged the screens? Because with the LCM we had to pump when we drilled it. Now we knew the reservoir pressure because we have a downhole gauge, and we also know from the buildup that we had high skin. So okay, the most likely problem here is that the screens are plugged. So to fix that, I don't know if the easiest option, but the option we thought of was to pump fluid across the screens to clean them. So at least dramatic option is probably I could say. So how are we going to pump this fluid? Now there was 3 options. The semi-submersible with a coil tubing, which is normal. Then the lightweight intervention with the vessel with coil tubing, as Shell just talked about. And all the people we talked to said, no, don't do this in January. This is not a winter activity. And so then we considered using a lightweight intervention vessel with a coil hose. So that's a small hose that you run on slickline equipment. That would give us the ability to pump downhole. So that's what we chose. So that's it. The setup is pretty easy. As you can see, I can't point to it because it's over there, but it goes from the reel, it goes under a sheave, over a sheave, hose into the water, and then into the well. So in theory, it's easy. So a bit more information about this hose. So it's a 3/4 inch hose. I have this is the real hose which we used. It's, as you see, about 2 centimeters in diameter. It has a yield strength that's about 5 times that of slickline, so it's strong. Burst pressure is about 50,000 psi, so even if you pump 12,000, it's well within the limits. But of course, because it's so small, and the diameter or the ID is so small, even if you pump at really high pressures, the rate is really low. So it's looking at like 15 liters a minute. Now the advantages would be, as we said, that it's not much equipment. It's easy to rig up, to use on slickline. And then you're less weather sensitive. And then, of course, it's lower cost because it's less equipment. and it would enable us to pump the fluid across the screens, which is what we wanted to do. Now, the challenges was that nobody used it in the subsea well. Nobody used it on a lightweight intervention vessel before, and it had never been deeper than 2,000 feet, and we wanted to go to like 9,000 feet. And also, it stretches a bit. So here's some pictures. So the hose on the reel, you see on the left, picture from the cab. So it looks like slickline equipment. It's just a hose instead of the slickline. And then the picture on the right is from yard testing. So the equipment fabrication and testing we did. So the subsea, I'll go more in detail on the next slides, but this is just an overview. So the things we made that hadn't been made before was a subsea stripper, so a stripper mandrel crossover, a production stab, and a coilhose nozzle. And then we tested the stripper in the yard, the same with the crossovers, and we also developed a nozzle for it. And then we tested the shear seal on the hose. And for lab testing, we did quite a bit of lab testing to decide which fluid to pump, and I'll come back to that. Right, so the subsea stripper. So a stripper is the same as a coiled tubing stripper. It's a packing that seals around the hose. So that wasn't very difficult. That's been done before. And the subsea one is the same one with different paint, I'm told, but just a few different connections. But the tricky bit was, so that will go up where the pink dot is on the well control equipment. So the first thing we had to decide was, okay, how are we going to control the hydraulics to the stripper? Are we going to take it straight down from the boat into the stripper, or are we going to take the hydraulics that go into the sill and then feed them up again? So we decided use the hydraulics we already had in the sill and then or modify that and take them up through the lubricator and into the stripper. So that was quite a bit cheaper, but of course it limits us on the amount of lines or hydraulic lines you can have available. So we built the stripper, and then we sent it to Norway to test in a test well to make sure we had an idea of how much hydraulic pressure we would use to seal around the hose. The wellhead pressure we had on the well was about 1,300 psi. So we wanted to make sure that with the hose stationary and with the hose moving, how much stripper pressure did we actually need? And also how much extra BHA weight would we have for the drag through the stripper? And we found, there was no leaks, and we had an idea how much pressure to put on it, and also how much weight to put on the BHA. And also, because we had two in tandem, we found that if you run with the lower one as your primary, then you can close the upper one. If you do it the other way around, you might spill a bit of oil between the two. So that was running with the lower one as primary was what we decided. And also to lubricate the hose as it goes in hole, because it's a bit sticky to get it in with high well air pressure. Then after we tested it in the test well in Norway, we needed to test the crossover, so between the stripper and the lubricator. So that is where all the hydraulic lines come from the sill up through the lubricator. It comes out through this crossover and then into the stripper. So we tested that, and we also tested that it screwed together and it held pressure. Now, one thing we did learn there, that don't test it horizontally, you should test it vertically. But most people probably know that. Right, so we had the equipment, so the main thing was to get this stripper right and the crossover onto the sill. Then what fluid are we going to pump? We had 4 different labs do the testing for us, and we gave them our oil, and we gave them the mud we had, and we said, okay, this is the filter cake, try to dissolve it. And they came back with 3 options. It was like acetic acid or lemon juice, or 2 different strengths of formic acid. And we knew that would dissolve whatever we had on the outside of the screens, and then we tested it with the hose. So we cooked the hose in it for 48 hours. Now the top picture, you can see that was what the hose looks like in the strong formic acid. And so we did that first. We thought stronger is better. Let's do that. And then we saw that. We thought, that's not going to work. So then we tested in the weaker one, and that's the lower picture. So that's what we went with. And in addition, so this the formic acid is what they call with a precursor, and that means that it doesn't form. It's not acid on deck. It only forms to acid when it's in the hole and it's heated up to like 100 degrees. And we also had a surfactant in there, corrosion inhibitor, and we mixed it in brine because there was some shale above us. Right, so for the nozzle, you see the hose is really tiny, and we have 6 5/8 screens. So to jet the screens, we thought, okay, we need to get closer to the ID of these screens. So we designed the nozzle, or QI designed the nozzle, and it was, so basically it's the nozzle, a turbine, and then swivels and centralizers on the side. And we did one nozzle, so okay, we don't have much fluid to pump, or the liquid rate is low, so we better focus it on one nozzle. And for the testing they did, so they tested the turbine and the nozzle in a horizontal pipe. Then they tested it in plexiglass tubing, so we could see it, that turns around. And then we had a piece of the screen, the same size, so we put it in mud for 3 weeks to make sure that, okay, we'll see for real, can it actually pump out through this screen? And yes, we can pump out through the screen, but it didn't come out it's not like a high pressure wash, obviously, because it's a low rate. But it was more like spotting, where we say, okay, we think we have the right fluid, so even if we just get it there, that will be fine for us. Then for sharing of the coil hose, so in the seal arrangement, there's the 7-inch share seal, and we hadn't tested that cutting the hose. So we're looking at the hose and we're looking at the seal, and so of course it's going to cut the hose. But, well, if it comes to cutting it with a share seal, then we better be sure. So the share seal from the enhancer wasn't available at the time, so the hose went to Houston and we cut it. And we now know that we can cut it with tension in it, and we can cut it without tension in it, and we can pressure up to 10,000 psi below it after. So we're fine. And there's also, or not obviously, but there's no damage on the blades. And you can see the guy there is testing. You can see the size of the share seal. And then from the operations, so as most of you are familiar, that's what it looks like on the top, and that's the schematic of the equipment we had on the seabed. So the idea for us was we're going to go to the well, we're going to drift it, we're going to do a caliper, run the hose to bottom, and pump our fluid. Now, as you see here, it's quite a few more runs than that. And the reason for that was mainly that we had trouble getting through the FLCV. And that meant that because we had a restriction through there, we couldn't use our special designed nozzle. So that was a bit of a blow, but we had a plan B. So for, as I said, we had designed the nozzle we could get closer to the ID of the screens, but that we couldn't fit that in there. So what we ended up with using was a smaller one that was designed for jetting safety valves. And when we tested it just before going in the hole, we saw, okay, we don't have enough rate to even make it turn, but we just have one nozzle in there. We said, okay, the difference between jetting a little bit and not jetting much, now we better just get the acid in the hole and pump it. So that's what we did. And here are some pictures of the operation. I don't know how easy it is to see, but I have a circle around where the coil hose winch unit is. There's a circle of the lower sheave, so it comes off the unit and then from the lower and then up to the heave compensated frame. And then on the right-hand side, you can see the stripper before it's going in the hole. And then, and here are some pictures taken from the ROV as we're running in hole, the tool string going in there, the open water latch and the stripper mandrel going in, and then as it's latched in. So total time, we spent 2 weeks. We had about 68 hours downtime, and most of that was weather, but that was for January or February that we were pretty lucky, I say. And of the whole operation, we spent 51 hours on the coil hose. And some of it was correlating the depth, and so a long time was pumping the acid, because we pumped about 30 barrels. So for lessons learned, and yeah, so the coil hose, as I said, it stretches. So it's, which makes it a bit hard to know where they are. Then to prevent this stretching so much, we pump fluid, full blast going in and out of the hole. And also the QI have these depth correlation tables, and okay, at this depth with this pressure, you are actually at this depth. And that, we found that worked pretty good, but also because we'd hung up on the FLCV so many times, every time we hit it, so we knew where that was, so that helped us. And another thing with the stretch is obviously when you pull out a hole, then you'll be on minus. So by the time you hit the stripper, you're not on 0, but you're on minus, I don't know, 500,000 or 1,500 feet. So you need to pull out a hole really slowly in the end. And since we had limited lines going to the stripper arrangement, we didn't have a tool catcher, so that meant we had to be extra careful. It worked, so, but there's maybe something to consider if anybody else wants to do it, that is something to think about. Now the outer layer is really, if you cut it, it's a problem for the hose. So we were really careful with make sure it doesn't go over any sharp edges, and we treat it very gently. So that we knew up front, and that we did, and that was no problem. It's a small nozzle size, because the idea of the hose is small, so of course the nozzle size were also small. But we had 2 filters in parallel and a screen on the inlet of the pump, and we pumped for 50 hours, and we didn't have any problem with that. So I think make sure either the tanks are clean and have filters on it. So we didn't have a problem, but there's something to think about. So obviously there's no injector on there, so it's gravity fed. So the higher the well air pressure, the more weight you need on your BHA. We tried to flag the hose with the paint, and we found that doesn't work. It just gets stripped up through the stripper. And yeah, so there might be other ways for the future to decide how to tag or to flag it. And we also had 1 stage high stripper pressure with air was trapped in there, and then we just need to cycle the stripper. So if you had more lines again from the sill, you could maybe put the 3rd one on there for contingency. So we only had the 2, and that worked. So in the 4 months from we started to think about this from a good idea to we'd done it, we didn't hurt anyone or spill anything. We doubled the production of the well. It's come down a bit before or after that, but we think we know the reason for that, and it's not to do with the job, it's to do with we have a shale formation above us that we think reacted with the acid. And yeah, so we were the first ones to put it into a subsea well, and then from a lightweight intervention vessel, and we put it safely to 9,300 feet and back again. And yeah, so it can always be used for other uses. And that's it.